Here I have a cartoon version, cross-section of a spine, and I am seeing these spinal nerves leaving and entering the spine. So I have both over here. Here's my spinal nerve, those yellow structures. This would be part of the peripheral nervous system. And over here I have the spinal cord being shown, cross-section. That's part of the central nervous system. It's very difficult to talk about the spine and not discuss their spinal nerves and what's going on there, because there's communication really with what's going on there. They're both retrieving and sending signals to the body from the central nervous system, that being the spine. There are a couple different concepts I want to go over here. The first concept is that spinal nerves are mixed. So what I mean by that, if I look over here, I've circled a spinal nerve. They're kind of coming together, both entering and leaving at some point, but they come together, the spinal nerve does. They are mixed nerves. What I mean by that is that I have sensory signals going to the central nervous system, those afferent neurons. I have motor neurons, or efferent. Those are signals going from the central nervous system to somewhere in the body. I have somatic neurons. Those are known as body neurons. Pretty much skin and skeletal muscles are going to make up that category. And I have visceral neurons. These are organs. Think of the heart, think of the stomach. These are going to be the organs that signals are going to or coming from. So spinal nerves are mixed for that reason. In addition, in spinal nerves, I pointed this out in a previous lecture, I have something called the dorsal root ganglion. What that is this bulging here. I see this bulging here of the spinal nerve. That has to do with the collection of cell bodies. If you remember what a neuronal cell looks like, terrible artist, but I'm going to draw my soma. That's a cell body, and I'm going to draw the nucleus of that neuron. That's a cell body, and then remember that it formed an axon. Cell bodies, many cell bodies are going to come together at this spot here. In fact, it's the sensory cell bodies, and only the sensory cell bodies that are going to meet together at that spot in the spinal nerve. That's called a ganglion. So let's actually look at the cross-section of our spine. That's really what I want to point out here in our lecture. So, and the different horns. So here I can actually see I'm going to color in the white matter. This is all white matter, named so for the appearance. White matter is going to be composed of myelinated axons of neurons. What I really want to point out is the gray matter, this butterfly-shaped area of the spine. In the gray matter, we have different spots where the nervous system is communicating with each other. We've got sensory neurons. Remember that the pathway is a sensory input, a signal going from the body to the central nervous system. Then we have interneurons, receiving that signal, processing that signal. So then the interneurons are going to form a decision, and they're going to relay that decision to motor neurons. We actually find this connection in the spine, in the gray matter of the spine. Let me actually point that out. So I'm actually going to follow a nerve here. It doesn't matter if you choose somatic or visceral, but I am going to choose a sensory nerve, and I'm actually going to show you the process through the gray matter of the spine and how the nervous system is communicating. So here, let me actually draw that pathway once again, sensory to interneuron to motor neuron. Okay, so you can have that on top. So here I'm going to pick my somatic sensory. Maybe that's receiving a signal. We'll use the nail puncturing the skin as an example, as you guys have seen, and there's going to be a signal that my nervous system wants to relay to the central nervous system, pain receptors, receiving that stimuli of the nail puncturing skin. So that signal is going to be sent over. Cell bodies of that afferent neuron is going to be located in the ganglion, and then that signal is then going to reach a synapse. that's going to promote the release of neurotransmitters in order to communicate with the next neuron. So I'm going to use a different color here. Now we've arrived at the dorsal horn of the gray matter. The dorsal horn, dorsal behind, back, posterior. I'm going to go ahead and write back of the spine here. Ventral's front. I'll go and write that over here of the patient. The dorsal horn then is going to hold the end bit of the sensory neuron, so the synapse bit, so an axon of that sensory neuron. So my interneuron is going to retrieve the signal from that sensory neuron. There's my interneuron there. There's another one. We actually have many in the dorsal horn. They're going to retrieve, process, integrate that signal from the sensory nervous system. Here I'm circling the ventral horn of this gray matter spinal section. The ventral horn is going to hold the cell bodies of motor neurons and the axons, the beginning axons of those motor neurons. So here are my interneurons. They've processed that information that they received from the sensory nervous system, that pain associated with the nail puncturing the skin, and it's processed that it wants the individual to move away from that stimuli that's causing that pain. Well, that information then gets sent over to the motor neurons. So I'll go ahead and highlight the motor neuron here. There's the cell body and the ventral horn and the axon, the beginning axon. There are other different motor neurons that are then going to relay that information over. I've now left the ventral horn, that gray matter, and now I'm part of the spinal nerve of the peripheral nervous system, and I can actually see that motor neuron trying to get to the spot of where it wants to get to. It's probably going to be a muscle that's going to cause that individual to move away, contract that muscle, get away from that stimulus that's causing that pain.